In the previous lecture, we had started looking at the concept of what is a set mathematically. So, we looked at some examples and we said that to manage things, we put objects in a collection. Objects could be of different nature, different type and so on. But we said mathematically, if we want to analyze this collection, we should have it is a well defined collection of well defined objects. So, the question comes, what does the mean well defined mean, and what does well defined collection means, and what does well defined objects in that collection mean. So, to understand these two the word well defined, let me illustrate this by some examples, so that we are able to go ahead. So, let us look at so consider the following collection of certain color dots. So, they are color dots given, and they are 13 in number. I hope they are 13 in number. Let us count. Yes, they are 13 in number. So, we are given 13 dots which are all colored, and question is, do you think this is a well defined collection? Well, you are given the objects, right. So, it is a well defined collection, that is no doubt about it, right. So, this is a well defined collection of 13 dots. There, you can imagine they are physically given you, you are given a physically a box containing these 13 painted cardboards, you can imagine, right. So, it is a well defined collection. Now, the next problem that I am going to ask you is the following: can we select red dots among these 13 dots? So, among this collection of 13 dots which are colored cards, you can think of circular cards which are colored. If I ask you to pick up the cards which are red and separately put them in a separate box. So, think it about a minute and try to write down on a piece of paper your solution. You can, if you like, okay, you can just count. For example, I may think this is red, 2 red, 3 and 4. I do not think this is red according to my selection. Your selection may be different, right. So, if you have if you are watching this video at home and you are in a class where you have some other persons also watching, you can play this game jointly and ask each one of them to pick up what is how many red dots are there in this, and you will be surprised to find you will find different answers from different people. Hardly any two we may agree what is what are the number of red dots in this. So, there is a problem. So, we have a problem of selecting red dots among the 13 dots. So, what does that mean? That means the term red or the color red means different to different people. It is not well defined. If it is well defined, means it should mean same to everybody, but different persons visualize what is red. So, among these 13 dots, how many of them are visualized as red depends on the person what he conceives red to be. So, the word red is not defined. So, it is difficult to find out the number of red dots in this. So, this is what not well defined means. Okay. So, this is what is called precision. So, for example, if you want to analyze the consumption of electricity by household customers in a particular city, you have a problem, you want to analyze how much electricity is being consumed by household customers in a particular city. So, of course, a particular city, that means we have to first of all define what is a city. So, probably you will that does not cause much of a problem, because a city means a well defined boundary as per the corporation or the municipal corporation of that city. So, city is well defined or by the electricity department. Okay. What is a household customer? So, we have to define what is a household customer. So, probably that is also well defined. namely if the electricity consumer that the line or the meter, electricity meter is in a house where a family or somebody is staying, that is a household, and it is not in a place where there is a business being done or a shop or something. Okay. And then third thing is what is analyzing the consumption. So, we should be very well aware of what is, how do you measure the consumption of electricity, and we have now very well devised instruments, meters which calibrated meters which measure how much somebody is using. So, here everything seems to be well defined. To formulate the problem, we need the data. So, as I said, we will, what constitutes a household, that we have to make it precise. What is the method of measuring consumption, that we have to make it precise, and we have to. That means what? That means nobody should be able to doubt whether what is a household, if we have said this is a household, and there shouldn't be any controversy or ambiguity in saying of measuring of the consumption of electricity. So, that is what well defined means. So, let us look at some more example. All students who have registered for this particular course, of course, that is a very well defined collection, because we have their names, we have their numbers, email IDs and everything, and the office managing these courses, they have their records. So, this is a well defined collection of all students who are registered for the course. All students in a school whose birth month is April, that's, we have a record of all students who are registered in a school, we have their birth records, and we can find out which one of them are born in the month of April. Okay, well defined. All salaried person in a city whose income is above 50 lakh per month. Of course, here we have to understand what is a salaried person. So, who is employed somewhere and getting a remuneration every month or every day or something like that. So, salary should be well defined, and income should be well defined. What is the meaning of income? So, we should be very well able, we should be able to say without any ambiguity what does income mean and what does salary mean for a person. Then only we can do any analysis of such data. All married working couples in a city whose income is above 50 lakh. So, that also is okay, seems to be a well defined collection. All income tax payers in the city. Well, so, all income tax payers, probably we will classify who file their income tax returns, they are income tax payers. So, is a very well defined collection. Set of firms in a city whose annual turnover is about 25 lakh. So, this may be a bit difficult to say which are the firms. So, this will only go by some official records when they have the audited statements of the firm, yearly audited statements where this disclose how much is the turnover. So, if you go by that method of picking up the firms, then it is well defined. Set of goods a consumer can afford to buy, normally it is called the budget set, meaning this is in the these objects, these goods, the consumer will be able to afford to buy because of his income or what. So, this is normally in economic terms is called the budget set of the consumer. The set of goods or services a consumer is physically capable of consuming is usually called the consumption set for the consumer. So, these are the terms coming from economics, and if we want to analyze them, make any study of these things, we should know clearly what is called the budget set and what is called the consumption set. So, what I am trying to show is how the nature of a collection of objects in a different context can arise to analyze different kind of problems. Let us look at some more examples. We want to analyze who are all the rich people in Mumbai. Well, can we say what is who is rich, who is not rich? It seems to be a problem in deciding what does rich mean. Can we say, can we go by the bank balance of that person, or can we say how much property he owns? And so, it is not a very well defined word that rich, what is rich mean, it is not very well defined, okay? Because given a person, we cannot categorize it as rich or non-rich. So, this is not a very well defined collection. Okay. So, rich in Mumbai is not very defined. Let us look at the numbers 2, 4, 6, 8 and 10. Here we are actually given the collection, we are given a box having the numbers 2, 4. So, it is a well defined, we are actually given hold of those objects, we do not have to pick up, right. So, normally such when the actual things are given, it is well defined. This is a well defined collection. Set of all students in a class whose name starts with the English English letter A. Yes, that is very well defined, because we know how many which are the students in a class. We have the roll list, we can pick up according to the names which starts with A or not. This is very well defined. So, naively, I hope we have understood what is well defined means. So, a set mathematically, a very naive definition of a set is a well defined list or collection of objects, okay, of well defined objects. So, the collection should be well defined and the objects in each of them should be well defined. So, well defined, we have not really given a mathematical definition of what well defined means. We have only tried to give you some examples which illustrate what well defined is. Okay. So, actually this is a very deep rooted philosophical problem in mathematics. In set theory itself, what is a set? And we will not go into it. In fact, in whole of mathematics, one does not define a set. Set is something that is given to you, only you manipulate things in a set. So, I will not go into it. So, intuitively we will understand what well defined means. So, a well defined collection of well defined objects, we will call them as set. Okay. So, we'll learn once we have defined what is a set, it is a collection of objects. So, objects in a collection are called elements in that collection. So, there is a collection of things. So, elements, there are objects in that collection. So, each object in that is called an element. Okay. So, they are elements. These elements are listed in. So, how is it a set written? We use the brackets, the flower brackets, and write down the elements inside, we separated with commas. For example, let us we have natural numbers between 1 and 9. Okay. We want to look at all even natural numbers between 1 and 9. So, we know that 2 is a even number, 4 is even, 6 is even and 8 is even between 1 and 9. Okay. So, these form a collection, and this collection mathematically is written by putting this bracket. This is called a left flower bracket, this is called the right flower bracket. So, we put these two brackets, opening bracket and the closing bracket, and the elements, the objects inside 2 separated from 4 by a comma, 4 separated from 6 by a comma and 8. So, this is how the set of all even natural numbers between 1 and 9 will be written mathematically. One uses the symbol belongs to. So, when we want to say 2 is an element of this, so we will write this as 2 belongs with that symbol in this set. For example, if A is an element of a set, we will write it as A belongs to A. Right. So, this is we are trying to now develop the language of set theory. In mathematics, we will find this becoming more and more common, and English will become less and less used in mathematics, because mathematical language is very precise and it has only one way of interpreting. So, a set is written by this way, putting in bracket and saying an element something belongs to the set A is written as A belongs to A, right. And if something does not belong, some object does not belong, then we put a cross against not, against belonging. So, B, this means does not belong to A. So, B is not an element of A is written as B with this belongs with a cross does not belong to A. So, A belongs to A, B does not belong to A. So, for example, in that 2, 4, 6, 8, 2 belongs to that set, because here is 2 sitting inside. So, 2 belongs, but 3 does not belong because 3 is not in this collection. So, we will write 3 does not belong to it. So, this is a typo here, it should be saying that 2 is an element of the set, while 3 is not an element of that set, right. So, it is very clear. So, this symbol is used, A belongs to A, the element A belongs to A, but the object B does not belong to A. And one thing more, elements are not repeated in a set. For example, when we are represented a set, this set as 2, 4, 6 and 8, an element is listed only once, its presence is shown in that collection only once, not again and again. For example, if we do not write 2, 2 again, right, only once is enough to indicate. For example, this 2, 6, 4, 6, 8 is not a valid description of the same set, because here we have repeated 6 in this representation. So, that should be avoided, that should not be written. So, elements when described in a set are not repeated. Okay. Right. So, let us go ahead a bit more and try to understand. So, in a sense, saying a set is well defined, right. You take up an element S, there should be only one possibility of saying either S is inside that set S or that element S is not inside that set. Okay. For example, in that example of rich people in Mumbai, if I pick up a human being, right, I should be able to decide conclusively whether he is rich or not. I can't say he may be rich or he may not be rich. So, that is what the well definedness amounts to be. So, for example, if F is the set of all divisors of 12, okay. So, here you should understand what is divisor of something that divides 12. So, 1 divides 12, 2 divides 12. So, 1 belongs to F, 2 belongs to F, 3 belongs to F and so on, okay. 6 belongs to F, 12 belongs to F. So, these are all divisors of 12. So, all of them belong to F, but 8 does not divide 12. So, 8 is not an element of F. Similarly, 9 does not divide 12. So, 9 is not an element of F. Okay. So, this is how the language of set theory is getting evolved. A set is a well defined collection of well defined objects, and if an object belongs to it, we denote it by that symbol belongs, and if it does not belong, it is not in that collection, we write it as it by a slash does not belong. Okay. So, this is set by description, right. So, let us look at some more examples. A set is, let us consider the set A is the set of all natural numbers between 2 and 9. So, what are all the natural numbers between 2 and 9? 3, 4, 5, 6, 7, 8. So, we have listed all of them. So, we write A is the set which is equal to, which is within the brackets, opening bracket, closing bracket, 3, 4, 5, 6 and so we have described all the elements. So, this is a set. Let us look at another set. V is a set of all vowels in the English alphabet. So, what is that? So, we know the English alphabet A, B, C, D and so on. In that, if you have the knowledge what is a vowel, so you can pick up, we know there are 5 vowels and they are A, E, I, O, U. So, we know precisely how to pick up a vowel from the alphabet, collect them together, put them in the bracket, and that is a set of all vowels from the English alphabet. So, that is a well defined set. So, this is a set by describing. We are describing all the elements of the set explicitly. We are showing you all the elements. The set of all divisors of 18, something we have done similar to 12. So, 1 is a divisor of 18, 2 is a divisor of 18, 3 is a divisor of 18, 6, 9 and 18 all are divisors of 18. So, F is the set, right. So, when we say consider the set F of all divisors of 18, we mean F equal to bracket 1, 2, 3, 6, 9 and 18 bracket close. So, this is how we write the set of all divisors of 18. So, this is called the set by description. Let us note while writing elements in a set in the above method, the order in which the elements are listed is not important. So, one we said when you are listing all the elements of a set, you should not be repeating them, an element should not be repeated, it should be listed only once. And secondly, it is not necessary that you should be writing in the same order which you think is a natural one. For example, the set 3, 4, 5, 6, 7, 8, this is a set whose members are this. All members are equal. We are not saying this is the first member, this is the second member, 5 is the third member or so on, or element of the set. You could have written this set also as 4, 3, 5, 6, 7, 8, okay, or 8, 7, whichever way. So, order of the elements when you are describing, it is not important in which order they are written. They all should be written and only once they should be written, that is what it says. Okay, right. So, for example, the vowels A, E, I, O, U, here we have written vowels as they occur in the alphabet from looking at A, B, C, D, so on, but I could have written it also E, I, O, U, A or O, A and so on. So, the different ways of writing the same set, they all mean the same set. So, the order in which the elements are listed is not really important. So, this is one method of writing a set where we are explicitly able to exhibit all the elements of that set. There is another method where we specify a rule for picking up those elements of a set. So, let me give some examples before we write. The elements of a set are described with one or more rules. The rule could be one or more. For example, the set of all natural numbers. So, one way is I write n. So, this is, by the way, this is the symbol we will be using throughout our course for the set of natural numbers. This is n with a additional line on the side. So, this is called script n. So, this is called script n, okay, and this will signify whenever you see this, this will mean the set of all natural numbers. So, what is the set of all natural numbers? 1, 2, 3. Of course, I could have written 4, I could have written 5 and so on, but we know that we cannot write all natural numbers, describe them explicitly. So, one writes 3 of them, 1, 2 and 3, and then puts dots to indicate that we go on doing that. Okay. So, this is one way of writing the set of natural numbers. Okay. Now, let us look at the set of all integers, right. What is the set of all integers? This is normally denoted by Z, Z, capital Z with a additional line in between, are also denoted sometimes by the letter I for integers. The symbol Z comes from the German word called Zahlen calculation, and because German mathematicians gave it first this name, this symbol, so it is used very often, or is used mostly actually, I would say. But some of the books in school they use I for integers. So, what are integers? Integers are, you look at all the natural numbers. Okay. Here is a typo here, along with that you should also have 0 inside it. Okay. So, what is the set of all integers? This is a correction here, set of all integers is 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3 and so on. Okay. So, that is the set of all integers. So, we can write x, x is an integer, or write as plus minus n a natural number, and I should be closing the bracket. So, there is a mistake here in typing. Okay. So, what is the mistake? The mistake is first, it is okay, z is the collection of all integers, and then I should be writing as opening bracket plus minus n, this line indicates such that n is a natural number and or it should be a 0, n could be 0, 0 is also a part of the integers. So, that is a way of writing the integers. Okay. Right. So, let me probably show it to you writing on a piece of paper. What does integers mean? So, integers z denoted by z is equal to, it is 0 plus minus 1 plus minus 2 plus minus 3 and so on. Okay. Or you can also write it as all n such that n belongs to n, okay, plus minus n or n equal to 0. This is another way of writing integers. Okay. So, either is good enough. So, this z is the letter which is used to indicate integers. So, let us go over to next one. So, as I said, this when I write this way, this vertical line means x such that is how you should read it and understand. So, let us look at P. Okay. For example, P could be the set of all x objects x such that. So, what is x? X is the President of India between 1947 and 1960. Okay. So, this is one way, and if we know precisely who are these people, one can put their names in it and write it explicitly also. So, in this method the elements of a set. So, what is the roster method or the rule method of representing a set? In this method the elements of a set are listed in flower brackets and each element is separated from the next by a comma, that is the explicit method of listing, right. These are described explicitly. So, this is explicit method of description of integers, right. So, the earlier one, when we said presidents in India between this year and this year. So, if we remember correctly, there is only one president, that President Dr. Rajendra Prasad. So, what we are saying is a set is a well defined collection of objects 1, and there are two ways of representing a set. One, by putting a flower bracket and listing all the elements of the set, or describing the objects by a property. Okay. So, there are two different ways of writing, whichever is convenient we should use them. Okay. So, we will stop here and continue our discussion of set theory.